Good morning. Welcome back to my UI class. Today, I would like to talk about how to use RNN to classify names of Hong Kong Pinyin. Let me explain what do I mean by Hong Kong Pinyin first. Pinyin or romanization of Chinese names sometimes can be confusing to non-Chinese. Here's an example. Recently, people searched the chairman of Evergrande, one of the biggest developers in mainland China. But interestingly, if you Google search the chairman of Evergrande, it will show you a name in mainland Pinyin or romanization, which is Xu Jiayin, start with XU. Well, but if you try to search Xu Jiayin at the Bloomberg Billionaires Index, then you will not be able to find his name. It's because Bloomberg does not use the mainland Pinyin system. Instead, Bloomberg used his Hong Kong Pinyin names, which is Hui Ka Yan, start with HUI. So which is clearly based on the Hong Kong Pinyin system, which is a unique romanization system based on Cantonese pronunciation. And that's the reason why in Bloomberg Billionaire Index, you will be able to find Hui Ka Yan instead of Xu Jiayin. Yeah, as shown here, rank number 431. Hong Kong Pinyin system is based on the spoken Cantonese language, which is the most commonly used language in Hong Kong. It is adopted in Hong Kong to standardize the romanization of local Hong Kong citizens' Chinese names, which gives a distinctive name in Hong Kong Pinyin. Here I provide another example. Chang is one of the most commonly used last name in Hong Kong, but in mainland Pinyin, it is CHEN, Chen, while in Hong Kong, it's CHAN, Chan, and in Singapore, it can be Tang, TAN, and in Korean, it can be Jin, JIN. So it may be resource consuming if we build a database to provide all these Chinese characters in different Pinyin systems to automate the classification. So instead, we make use of machine learning, and based on the recurrent neural network approach, we developed a Chinese names Pinyin classifier for classifying names in mainland Pinyin and Hong Kong Pinyin. And also we applied this classifier to test the price differences between mainland buyers and Hong Kong buyers in the housing market of Hong Kong. For more details, you are welcome to download this open access paper by Chan, Lee, and Yu, 2021. So of course, the machine learning algorithm is versatile, which can be applied to different languages. The algorithms make use of the position and sequence of alphabets, but then a user have to provide your own set of data to train the algorithm, and also have to adapt the algorithm to your situation. So as a demonstration, this article focus on the example provided to classify Chinese names between mainland Pinyin and Hong Kong Pinyin on Google Colab platform. So these algorithms does not require researchers to understand the difference in the romanization rules because it is based on a machine learning approach. Researchers only need to provide examples of the pinyin of names for training purposes. The algorithm will then learn and identify the hidden rules based on the examples provided. What do we mean by RNN? It is a kind of machine learning tool based on the gated recurrent unit. So here the diagram shows you the example. So instead of learning from the input layer to the hidden layer to output layer, you will find that it provides with a memory. So that's the algorithm that remembers its input with an internal memory, so which make it perfectly suitable for machine learning problems that involve sequential data. So just like this example, when we are going to classify names, which is a sequential data, then RNN is suitable. For details on the Chinese names classifiers, it is available at the GitHub of Chen 2022, the link provided here. And for more details and explanation of the algorithms, you are welcome to download our paper, Chen, Li, and Yu 2021, while I try to adapt the algorithms to run on the Colab platform for this article. And just for demonstration purpose, we focus on the 03_example file in the GitHub, which provides a pre-trained model with all the training materials provided for downloading. So the steps are straightforward. The first step is to download the training materials at Chen's GitHub. There are 3 files available stored in the models of directory. Simply click the models of directory and download the 3 files. In my examples, I open a new subdirectory in my Google Drive, named it Google Colab Lookbook / model / to save the 3 files so that I can make use of these files at my Colab platform. Then step number 2, we open Google Colab at this link, and we open a new Colab Lookbook, which can run Python codes. And we simply import these Python codes into the Colab platform and run it. Let me show you directly how to do that. Okay, once again, search Colab. Welcome to Google Colaboratory, Google Research. You can open a new notebook, and you can give a name. Here, for example, I give the algorithm's name as Chinese names classifier. It is basically adapted from Chen's 2022 GitHub here. And I copy and paste the first block, basically import most of the subroutines to run the machine learning algorithm. But before that, I would like to emphasize that we have to open the GPU first, and you can click Edit and Notebook Setting and Hardware Accelerator and choose GPU to make it more powerful to run this big algorithm. Okay, so then copy and paste the routines, then you click Run, then it will show you whether it is successfully operated or not. Then it shows a tick. Then the second block is very simple. We simply mount my Google Drive, and you will ask for permission. Yeah, so if the permission is granted, then the Google Drive will be mounted. Then the third block would open the 2 files. One is the tokenizer, and the other is LE. And using the GRU models, here you will find the directory, which I use my drive, Google Colab Lookbooks models tokenizer.pk1. So we have to make sure that the files are saved in this directory. Right, in your case, if your directory's names are different, remember to change the names of the subdirectory accordingly. So if okay, then run this routine. So basically you draw the pre-trained model and the set of data. And then the 4th routine tried to define the 2 processes. One is process X and the other is predict name. Make use of the keras to process the data, and then use the predict name algorithms to tell whether it is Hong Kong Pinyin or mainland Pinyin. Let's run it. Okay, then let's try. Here, I provide the example using Hui Ga Yan and Xu Jia Yin, right? The same person's name, but the first one is in Hong Kong Pinyin, and the second one is in mainland Pinyin. Make use of the GRU model, tokenizer, LE, and see whether it can predict correctly or not. Yeah, so after running, then it tells you its prediction. The Hui Ga Yan is predicted to be a Hong Kong Pinyin, while the Xu Jia Yin is predicted to be a mainland Pinyin. It's correct. So you can try other names and see whether it is accurate or not. That's all for today. Thank you.